Hi, I'm Nunzio Motta, and today I'm going to show you how to prepare graphene in ultra-high vacuum and how to measure it at the atomic level by using a scanning tunneling microscope. Please come and have a look at the lab. And this is our ultra-high vacuum system with a scanning tunneling microscope in it. The ultra-high vacuum is required because we want to see the surfaces at the atomic level. So we need to remove any contaminants from the surface that is normally present in the atmosphere. So we create a vacuum inside this system by using special pumps that are below this bench. And you can see here the manipulator that is required to move the sample in and out from the system, and the scanning tunneling microscope here, that is where we are going to acquire our measurements. The manipulator is also used to heat the sample at a certain temperature to create that very clean surface that we require. And now let's go and prepare the sample. Now let us take a piece of silicon carbide. This is a special wafer that we buy and we cut. We put into the beaker and we go and wash it into the ultrasound station. And now we're going to wash the sample by using some solvents and ultrasound in order to make sure that the sample is really very clean before entering to the vacuum. So what we do, we fill this beaker with solvent, in this case is alcohol, and we can repeat this with acetone and deionized water. And we start the ultrasound. And this goes for a couple of minutes. Once we finish and we do the 3 times cleaning, we go back to the bench and we start preparing the sample onto the sample holder. Okay, now that we have prepared our sample, we are going to mount it onto the sample holder. So this is our sample, and this is the sample holder that is made usually of molybdenum. This one is made of tantalum, and is a very high resistant material, is a refractory material that can resist very high temperature. So what we are going to do, we are going to put the sample across here. We are going to put some special attachments here to make a good contact. The sample is going to be heated in a direct current mode. That means that the current will flow through the sample. And I need to put also these insulating rings here. And I need to screw in these nuts to get the sample secured to the sample holder. And I use this special tool in order to screw in the nuts. We just do a little bit of shaking to make sure that we secured it well. Yes, it's well attached. Okay, now we are going to check the resistance of the sample because we need to pass current through the sample, and we want to make sure that the resistance is in the right range. So we are going to use this ohm meter, and we measure the resistance between the 2 ends of the sample, and it should be in the order of a few hundred of kilo ohm. Okay, now what we are going to do, we are going to open this fast entry lock. That means that we need to fill it with some air or nitrogen. In this case is nitrogen. Once the fast entry lock is fully open, okay, that takes a little while, we can put the sample onto the transfer arm that will bring it into the ultra-high vacuum. Here we are. Okay, now we are going to transfer the sample into the system, and the first thing to do is to mount the sample into this transfer tool. Now we take the transfer tool onto this transfer arm, and we make sure that it slots in. We need to close down this port and start the pumping. Now I open the valve to the fast entry lock and I start the turbo pumping by pressing this button, and I will look at the pressure going down on this gauge. Now we check the vacuum before introducing the sample into the main chamber. The vacuum in the pre-chamber is good, 2.0 10 to the minus 7 millibar. So now we are going to open the valve that connects the pre-chamber to the main chamber. Okay, and then we introduce the sample. And we put the sample holder into the manipulator and rotating this to open the tweezer, going back and rotating back and moving back the transfer arm. And finally, we close the valve. Now I have a quick look at the gauge. The vacuum is recovered after the transfer of the sample, and now we can move the sample into the position where we will prepare it. So we need to move at the position that is Z equal 9, that is here. Here we are. Okay, now we point the pyrometer to measure the temperature, and we go to the computer to control the current in order to heat the sample. So this program here allows us to control the power supply, and we set up the desired current. We need a preheating step in which the silicon carbide goes to 600 degrees in order to clean the surface, eliminating all the contamination that is on the surface. We need to keep an eye onto the gauge all the time, that is here represented, in order to avoid any contamination during the formation of graphene. And now we can see how the graphene grows. Let us start increasing the temperature to a value that brings the sample to 1,200 degrees. Once we are nearly there, we set the desired current, 1,250, and we activate the PID. That will keep the temperature at that level for 5–10 minutes. Once we have that for 5–10 minutes, we are nearly sure that the graphene is formed. We need to keep an eye at the vacuum that does not bypass 5×10 to the minus 9 in order to have the perfect, most clean graphene surface.
Graphene is formed from silicon carbide when it is heated to about 1200 degrees. As the silicon atoms leave the surface, the residual carbon atoms rearrange into a hexagonal network. The longer the heating and the higher the temperature, the more silicon leaves the silicon carbide and more layers of graphene are formed.
Now that our sample is well cooked and hopefully we prepare graphene, we are going to move the sample from the preparation position to the STM by moving this transfer arm. Okay, now that the manipulator is in the right position for the transfer, we open the valve between the two chambers. We always need to check that the vacuum is okay. And once the valve is open, we use our special tool with these tweezers to grab the sample and place it into the microscope. Okay, now we are going to place the sample into the STM position by sliding the sample into the slot. Now that we have put the sample into the slot of the STM, we are going to do the measurements. So we are going to go to the computer and use it to control the STM. Okay, after we start the STM program, we can control the position of the tip. The STM is based on a quantum mechanical effect, in which we approach the tip to the surface to a very short distance of the order of a few nanometers, and the current that is due to a quantum mechanical effect is flowing. We can control the current by using our piezoelectric system to the level of the atomic resolution, so we are able to see the atoms. Okay, when the tip is close enough, we can have a look at the high magnification microscope window that is here, and we can start approaching slowly. You can see that this moves very easily if you touch the system. And now, what we are going to do, we are going to set up the automatic approach. The program will find the optimum distance to obtain the required tunneling current. By controlling the current flow, we can control the distance between tip and sample to the atomic level. Here we are. Tunneling current detected. Let's start the scanning. When we scan, what is here on the screen is a representation of the tip movements in Z and in X and Y. And these movements are actually following the atomic structure of this surface. And here we are. We see the graphene. You see there these little spots. These are the graphene atoms that are coming out. And the black dot is actually the representation of a graphene hexagon. You can see onto this XY graph the representation of the movement of the tip. And you see these little bumps here. Each one is a graphene atom. Once you are there, and if you want to look closer to what are the shape of the structure that you see, you can zoom in with your computer and look at an enlarged version of the image. This is actually a scanning that is getting much more precise. So you can really get measurements of the distance between the atoms. It is beautiful to see how nature creates ordered structures. Look at this hexagon of the graphene. They are fantastic. Don't you like them? Okay, we have seen these beautiful graphene structures. It's all about the atoms finding the minimum energy configuration. I hope you enjoyed this video. And if you need anything and if you want assistance, we'll be very happy to help you. You can come and see any one of us and we will assist you.